Good morning, everyone. In this video, we're gonna learn how to compute relatedness density and use it to predict entry. So this video is very much tied to the one where we compute relatedness between products, between economic entities. And in this video, we're gonna use this relatedness, this product space, to actually predict something. So we're gonna predict the type of new products customer will buy. We're going to predict the type of economic activities a region will diversify into. So this has, again, a lot of potential, but make sure that you really understand how to compute relatedness between entities before proceeding further in this video. So most of the functions we're going to use here are already included in the econgeo package. So in this case, we're going to start by creating some data that we're going to use for this video. So let's use this data set here that is included in the econgeo package. So I generate a matrix called mat that basically tell me how many specific economic activities are in a given region, in a given industry. So in this case, for instance, Region 1 might have 52 employees in Industry 1 and 45 in Industry 2. You could also think that these are customers here and these are products in column, and the cells basically tell you the intensity of like how many products a specific customer buys. So that can be, this is very generic, it can be whatever you want, but in this example, we're going to use the idea of regions and industries. So first step is we're going to compute a matrix of comparative advantage. So instead of having numbers, we basically want to simplify this economic structure and know whether a specific region has a comparative advantage in a specific industry, meaning producing more than what you would expect based on the size of this region and based on the size of this industry. So basically it's an indicator of specialization. Is region 1 specialized in industry 1 or not? So binary metrics here to make things a little bit easier. So first thing, we compute a matrix of co-occurrences between industries, and then we're going to compute a matrix of relatedness based on the co-occurrences between industries. That's what we did in the previous video as well. And just to simplify again a little bit, we're just going to look at 0-1 relatedness, so whether two industries are related to each other or not. So this is our starting point. There are two very important things that we need to go further. First one, a matrix of relatedness, our product space. So that's going to be our tool to predict entry. The second one is a matrix where we know by whom these industries are produced. So you see here the columns perfectly match. This is very important. And we know that Industry 1 is produced by Region 1 and by Region 2 and by Region 5. Again, if you would have a matrix of relatedness between products, here you would have the how many you would have a list of customers and exactly the same products. So that's going to be the input we need to proceed further. So the first thing we're going to do is to compute relatedness density. So what we're looking for here is like we try to know whether industries that are related to Industry 2, for instance, are present in Region 1 or not. So in this case, and this is the tricky part, we're moving from the relatedness between entities, so you have a matrix with exactly the same dimension, 4 by 4, into a relatedness between regions and industries. So we're switching the unit of analysis, which is sometimes a bit difficult. So what we're going to do is use the function relatedness density between mat and r and create an object rd. Okay, so that's like literally what's happening here. And what you have is a matrix like this. So relatedness density ranges between 0 and 100. If you have 0, it means you have no industry related to the focal industry. If you have 100, it means you have them all. Let's dig into that. let's look here. We see region 1 and industry 1. The relatedness density between region 1 and industry 1 is 50%. What it means is that if industry 1 is related to 2 industries, region 1 has one of these 2 industries. So let's look at it in details. Let's first look at our product space. That's the easier thing to understand. So we look at our product space and we see that industry 1 is related to 2 other industries. Industry 1 is related to industry 2 and industry 3. Well, now let's look at our metrics for region 1. And we see that region 1 has basically one of this industry. So region 1 has industry 2, but not industry 3. So again, industry 1 is related to industry 2 and industry 3. And region 1 has industry 2, but not industry 3. So out of the 2 industries that region 1, out of the 2 industries related to industry 1, region 1 has one of the 2. It gives you 0.5, which means 50%. So now if you look at the relatedness density, this is why you get 50 here. So now I invite you to play with these metrics, also use other type of data sets, and make sure that you understand why you get the numbers you get here. Okay, this is our relatedness density metrics, and that's going to be the tool we'll use to make prediction. Now, let's just make it in a different format. Let's make it in a edgeless format, just because we're going to do some econometrics and it's going to be easier to have it in this format. So here count basically is like the relatedness density count. So it tells you that the relatedness density between region 1 and industry 1 is 50, and the relatedness density between region 2 and industry 1 is 100. So you expect, if industry 1 is not yet in region 2, you expect industry 1 to really enter in region 2. That's basically what it tells you. So this variable here will be our predictor variable. That's what we're going to use to predict entry. And we're going to use the function entry list to help us to construct a matrix of entry. So let's look at it here. Let's copy and paste until this point here. And now we have 2 matrices. We have mat1, okay, mat1 here, and that's going to be the world in time t. And then we have mat2, and that's going to be the world in time t plus 1. Now, let's look at these metrics a little bit more in details. So if we look at this, we see that in time t, region 3 is not specialized in industry 1, or customer 3 hasn't bought yet product 1. And what we see in the second time period is that region 3 has basically entered. Now, what you see also here is that region 1 was specialized in industry 1, in time t, and in t plus 1, it's still specialized. So there is no entry, but there were no entry possibility, just like maintain. So the entry possibilities are only when you have a 0 in time t. That's when you can enter. If there is a 1, it means like you will have to exceed, but you cannot enter again. So when you create an entry list using these 2 matrices as an input, first the time t, second the time t plus 1, and you can look at the documentation here to have like more details. Well, that basically gives you something very interesting, because it gives you also NA. So region 1 already had industry 1, so it could not enter. That's what it tells you here. It's not a 0, it could not enter. Now, region 3 could specialize in industry 1, and it actually did. That's what we just looked at. So that's why you have a 1. Now, industry 1 was not in region 4, and it's still not in region 4 in period 2. Look at it. We're talking about region 4 and industry 1. Well, region 4 didn't have industry 1, region 4 still does not have industry 1. So basically, this is why you have a 0. You know, there were potential of entry, but no entry at all. Here there were potential of entry, but and there's been entry. Here there were no potential of entry. That's the end. So make sure that you really understand that before moving further. Now we're just going to rename this column name here. So in this case, you know, we get region industry entry period because it's going to match with our relatedness density data frame. Because remember, relatedness density data frame was like this: region industry count, and now we have region industry entry period. So what we're going to do is we're going to merge these two data sets, not by region, not by industry, but basically by region industry. So that's what you do here. We merge, and now what we get is an augmented data set where we have for every region industry whether there's been an entry or not in a given period, and also our relatedness density count here. And we're going to use this variable to explain this one. So that's basically the literature on relatedness. That's what we're doing. We're trying to explain and to see whether it works or not. So that was basically what we've been doing for like a couple of years now, trying to estimate how much relatedness density impact entry. Okay, that's basically the different thing we were talking about before. And if I run a little econometric model using the summary function and a regressing entry on count, you know, a very simple basic econometric model, what I have here is basically my my coefficient to estimate the impact of relatedness on the entry. More or less, like what we found in the literature is that if you increase relatedness density by about 10%, the probability of entry increased by about 40%. So it's virtually always significant. That's what we call the principle of relatedness, and the impact is very, very strong. And of course, what you can do in a research project is to estimate the impact, so to know whether relatedness plays a role or not, whether it's important, whether it's mediated by other variables, and then you can also use it to make prediction. So you time t plus 3, then in this case does not exist yet, and you're going to use relatedness density to make prediction and know where a specific industry is more likely to enter.